In this problem, we're being asked to write the electron configuration of several different ions. And if it doesn't say so, assume that you're doing it for ground states, meaning all the electrons in their lowest possible energy states. When you're doing it for an ion, you always want to begin by doing it for the atom itself. So let's do oxygen first. If we look at a periodic table and locate oxygen here, we find the noble gas that comes before it, which is helium. And then we work our way across until we get to the oxygen. So this is the 2s block, or that isn't a 2, 2s, and then we have 2. Then we come into this area, and that's the 2p, and we count over, and we get 4. So that is oxygen, and we'll write that down here. Helium, 2s2, 2p4. Now we're ready to do it for the ion, which is O2-. This means we have 2 more additional electrons to place in. They go into the next available energy states. Well, we have only put 4 of the electrons in the p, and we know that a p is 3 orbitals, therefore it holds a total of 6 electrons. So we can put those 2 additional into the p. That will give me helium, 2s2, 2p6. Now let's look again at the periodic table. If we're putting those 2 additional electrons in 2p6, we now have the electron configuration of neon. So it would be equally correct to call this Ne in square brackets. So it's got the electron configuration of that noble gas. Let's move to the next one. We're going to do phosphorus first. So we find phosphorus on the periodic table, which is right here. We find the noble gas that comes before it, and that's neon. And we work our way to phosphorus. So we're going across until we hit here. This is 3s. We have 2 in the p block. That's the green area. And then we have 3p, and we count over 3, 3p3. So it's neon, 3s2, 3p3. Okay, so now we're ready to do p with a 3- charge. We're going to put the 3 additional electrons in the next available location. So that would be neon, 3s2, and 3p. Now we can go up to 6. Again, if we look at the periodic table and those 3 additional electrons going on gives us an argon electron configuration. So we could also equally call this Ar in square brackets. Okay, let's do a cation. In a cation, sorry, this is C. In a cation, again, we want to do magnesium first, and then in a cation, you're removing electrons. So let's find magnesium on the periodic table. I'm going to actually clear out this page so that we can not have things getting in the way. And we're finding magnesium. It's right here. So the noble gas that comes before magnesium is neon. 1, 2, 3. This is a 3s. And magnesium is 2 boxes over, so it's 3s2. So neon, 3s2. So magnesium with a 2+ charge, you're now going to be removing 2 electrons. They come from the outermost shell, highest N available, so it's these 2 electrons we're going to take out, and we would put neon. And so that would be the electron configuration of magnesium with a 2+ charge. Now very often students will think, well, magnesium's got 12, let's just move back 2 and let's do the electron configuration that's 2 before it. And that works for some elements, but that doesn't work for all elements, as we're going to see here. Let's do chromium. Chromium is D. All right, so we're doing D. Chromium's electron configuration, as we locate it here, the noble gas that comes before chromium is argon, so we have argon. We come over to this block and we count down 1, 2, 3, 4, so this is a 4s, and we have 2, and then we enter the D block, and D start with the number 3, so this is 3D, and we count over 1, 2, 3, 4. Now we learned that when you do electron configurations of the transition elements, if we have 4 or 9 here, we're going to promote 1 up. So chromium is actually argon 4s1 3d5. So let's write that down. Argon 4s1 3d5. So now we're ready to do chromium 3+. So we have to remove 3 electrons. We do not remove the last 3 we put in. We look at the valence shell and we take out the highest N first. We're going to take one of these away, and then we go to the D and remove a couple of those. So that's going to give me argon 3d3. So if we look at our periodic table, it would not be correct to say, okay, it's got 3 less electrons, so let's count back 3 and let's do the electron configuration of that element. So if we did that, we would have argon 4s2 3d1. And that is not the electron configuration of chromium with a 3+ charge. Last one is silver plus, so let's do silver first. Find silver on the periodic table, it's down here. So we find the noble gas that comes before it, it's krypton. So we write, well, let's go ahead and write it down here. Krypton. Work our way over to silver. So this is 1, 2, 3, 4, 5. 5s2. And then we enter this area, and that's 3d, this is 4d, and we count over and it gets us 9. So 4d9. Again, if we're 1 away from filling it up, which is 10, we would promote up. So instead of being that, it's krypton 5s1 4d10. So that's electron configuration of silver. Krypton 5s1 4d10. Now we're going to have silver plus. This is the only stable ion of silver, and that's because it's going to remove that 1 electron from here. So this is going to be krypton, and we're going to completely fill up that 4d subshell, and that's a very stable configuration. So don't forget, it's important that you do the electron configuration of the atom first and then remove electrons. It's not so important for the anions, negative charged ions, because you're just going to put them in the next available ones no matter what. But if you get in the habit of always doing it for the atom first, then you'll remember, okay, I look at that and then I remove them from the highest end before I start removing them from ends that are smaller.